Welcome back to linear algebra. Let's go into Anki. Anki. All right, 5, 6, 5, 6. Actually, flashcards. What is the size of an augmented matrix of a linear system of m equations and n unknowns? Well, it's gonna have m rows and n plus 1 columns. If A and B are square matrices, what must be true for the equation A plus B squared equals A squared plus 2AB plus B squared to be valid? A and B must commute. What is the forward phase of the algorithm for solving a linear system by Gauss-Jordan elimination? Forward phase is process of eliminating or introducing zeros below the leading ones. Part of Gauss-Jordan elimination in which zeros are introduced below the leading ones. Of what matrix is A to the power negative n the inverse? It's the inverse of A to the power of n. If A is an invertible matrix and K doesn't equal 0, how might you write K times A, both the inverse of K times A, as a scalar multiple of A to the inverse of A? The inverse of K times the inverse of A. What 4 properties must a matrix have to be in reduced row echelon form? 4 properties. All the rows of zeros only are grouped at the bottom. The first digit or first entry in rows that aren't all zeros is from reading from left to right is a 1. Rows sequential consecutive or rows, 2 rows that don't have or 2 rows that are not all zeros. The one with the right or more, leading one is below, and each column with leading one only has zeros and the leading one itself. Successive is what they call them. Other than that, looks good. All right, that's everything. So what I'm gonna do next is grade the work I did yesterday, and then I'll go from there. We got both sets of equations, or both problems correct. So what I'm gonna do now is continue to do 2 more problems, and then work on more Anki flashcards. All right, well, I didn't get to any flashcards today because I spent the whole time doing the 2 problems. So first problem was basically to give us this matrix with a bunch of unknowns that are all C. And it's basically asking what values for C make this matrix invertible, if any. And what I basically found was I couldn't turn this into C minus 1 into a value of 1 with only multiplying it by a constant. Oh my gosh, could I? Maybe I could. If I said C times 1, or C minus 1 times 1, yeah, no, I don't think it can, because if I times it by 1 over C, it's going to be 1 minus 1 over C. And then what do I times it by? C again, so yeah. Basically, there's no values that will make this matrix invertible. That's what I think. We'll see tomorrow if I got that right. This one was basically express the matrix, the inverse of this matrix, as a product of elementary row operation or elementary matrices. So I believe I did this correctly. What I did was this was the first, so right, the first time I multiplied through by 1/4 the second row. And so the first matrix I added was this one, which is an identity matrix with the second row multiplied through by the 1/4. And then what I did was took negative 3/4 times the bottom row and added that to the second row. And so I did the same thing. And see, I'm working backwards. I put this here later just because I had space on this side only. But I'm working from this one first and then backwards for each matrix. And I think that's the right answer. If you multiply this way, you'll get the inverse, I believe. Well, we're going to find out tomorrow if it was going the wrong way, but I feel like that was the right way. I would have checked the answer, but I just ran out of time, so that's it for today. Talk to you tomorrow. See you.